going to take another look at Hopital's rule. We initially did this in 3.1. And the reason why we're coming back around to it is going to be helpful to us when we work 7.7 next week. You can do Hopital's rule to find some limits. Today we're going to look at the ones in the form of 0 over 0 and infinity over infinity. Those are called indeterminate forms. How do you know if you have those? Try to directly substitute it on the problem. On this first one, 1 to the 4th is 1 minus 1 is 0 over 1 minus 1 is 0. So 0 over 0 says, hey, let's find this limit doing Hopital's rule. To use Hopital's rule, you do the derivative of the numerator, which will give us 4x to the 3rd, over the derivative of the denominator, which is 1. And then you try to directly substitute in again. Now when I substitute in the 1, I don't have the 0 over 0. I can get 1 cubed is 1 times 4 over 1, which is 4. And that, students, is my limit. This one is a limit as x approaches infinity. Infinity to the 3rd, well, that's a really big number, plus 5 is a really big number. So we'd have an infinite quantity in the numerator, and in the denominator we'd have the same, because infinity squared plus 1 would be an infinite quantity. We're going to apply Hopital's rule, which says find the derivative of the numerator, 3x squared over 2x. And now we're going to resubstitute into infinity for the x's, but still going to be an indeterminate form of infinity over infinity. Don't despair, you repeat the process. Derivatives again, 6x over 2. And this time, when we plug in infinity, we'll have 6 times infinity, which is a really large number, divided by 2. Folks, a really large number divided by 2 is going to be infinite. So we can say the limit does not exist, or we can be more precise and say that it approaches infinity. Down here, we've got another as x approaches 0. 2 times 0 is 0, well, e to the 0 is 1, minus 1 is 0 over 0. Go into Hopital's rule. Don't forget you need chain rule here. E to the 2x times 2. The derivative of this is 1. Let's try it out again. Substitute in the 0. 2 to the 0. 2 times 0 is 0. E to the 0 is 1 times 2. It looks like our limit will be 2. And this bottom one is another limit as x approaches infinity. Natural log of a huge number. Here's what the natural log graph does. It slowly increases, which means the numerator would be infinity and the denominator, any squared, would be infinity. We'd have that indeterminate form. Let's go ahead and do derivatives. The derivative of natural log of x is 1 over x. The derivative of x squared is 2x. Let's try to sub in again. 1 over a large number. Well, 1 over a large number means I have one piece maybe out of a million pieces, or 1 out of a trillion. Well, that's going to approach 0 over, even if the bottom is a large number, well, 0 pieces out of a large number is going to be 0. There you go.